Uh, okay. Hello, sir. The topic of our project is term deposit prediction system. So, why we have chose this project is because banking is one of the crucial sector in day-to-day life in the real practical world, where a lot of people walk up to the banks, do a lot of investment, avail loans and policy, and deal with a lot of transaction. And hence, we have basically chose a data set which reflects the real life practical world and make use of that data and derive great insights out of it. So the problem statement of our project is basically a term deposit prediction system where we have basically taken customers data of a Portugal based bank, and the goal of the analysis is to make predictions using a model that whether the customer will take the term deposit plan or no. So it's going to basically predict that yes or no, these two values. And for this we have used logistic regression model, logistic classification model. And now I'd like to call Sakshi to take us through the next steps.
So let us take a look at the available features. So the bank client data, that is age, job, marital status, education, default, housing loan, personal loan, and attributes related with the last contact of the current campaign, contact month, which is the last contact month of the year, day of week, duration, that is the last contact duration, other attributes such as campaign, that is the number of contacts performed during this campaign, p days previous, which is the number of contacts performed before the campaign, p outcome, that is the outcome of the previous marketing campaign, and other social and economic context attributes such as employment variation rate, consumer price index, consumer confidence index, and the number of employees. The output variable, that is the target, is y. It has binary values, that is yes or no. So let us start with the implementation of the model. So we first import the required packages and the libraries. So next we'll import the data, and head function basically shows us the first six rows of the data set. We'll take a look at the dimension, which is 41,188 rows and 21 columns, including the labels and the features. So we'll take a look at the internal structure data and the summary. It basically tells us about the data types which are present in each particular column, and the minimum, maximum, median, and all such values for each particular numeric column. Let us take a look at the distribution of the target variable. So with the help of cross table, we can find out the number of rows which says yes to the subscription and no to the subscription. So we'll first create a binary dependent variable for the regression model. So we'll convert the yes and no, which is in the column y, to 1 and 0. So it will be easier for us to handle. We'll take a look at the distribution of the target variable in the form of a histogram. So we can see that the number of people subscribing to the term deposit is less in proportion to that of people not subscribing. So we'll define the default theme for the ggplot and the mosaic plots. So let us start with exploratory data analysis. The first is univariate plots. So univariate plots are plots of individual features without the interaction of other features. So we can completely understand if a particular feature is affecting the value of y or not. So first is age. So in this particular graph, we can see that there are two intercepts at the x-axis, which is at age 30 and 60. So it basically tells us that the number of people subscribing to the term deposit at age 60 is far more than people subscribing at age 30. So let us try to slice the age and divide it into three parts, which is high, mid, and low. So we will high for age above 60, mid for age between 30 to 60, and low for age below 30. So and accordingly plot a graph for the same. So with this we can see that people with high age have subscribed more as compared to people with low and mid age. So here's the cross table for age. So here we can clearly see that 45.5% of people over 60 years old have subscribed to the term deposit, as we have seen in the graph. Let us take a look at the jobs, if they affect the Y variable or not. So here's the cross table and the graph for the same. So here we can clearly see that there is a higher response among students and retired people as compared to other jobs. Let us take a look at marital status, if it affects Y variable or not. So we can clearly see from the graph that singles are more likely to say yes than divorced or married people. So contact, it basically tells us that if contact which was made during this particular campaign, it basically tells us that the the last duration and the contact which was made to the users in this particular campaign, and let's see how it affects the Y variable. So here's the cross table for that and the graph. So so it basically tells us that 14.7% of the cellular responders subscribe to a term deposit, whereas only 5.2% of telephone responders did. The next is education. So here's the cross table and the graph. So here we can clearly see that education doesn't actually affect the Y variable that much. Now I'd like to call Mahima for bivariate analysis.
So for bivariate analysis, we are going to take a couple of social and economic factors like employment variation rate. This rate basically gives an idea of how many number of people are employed and are not working. Second is consumer price index. This is basically used for inflation, where it tells the rate of the change of the price of good and products over a period of time. And then we have consumer confidence index, which basically tells that how optimistic are consumers with regarding to the economical situation. And fourth is the Euribor 3 banks rate. So since the data set belongs to a Portuguese bank, which is nothing but a European country, so this term tells us that uh, the rate of the funds and loans given by the banks to each other in euros. And the last feature that we are going to take in consideration is the number of employees in the bank. So moving down further, so basically, this is a correlation matrix which gives the correlation between the different features. And here we can clearly see that the employee variation rate, obviously with the employee variation rate will be 1, but with other features, for example, like the European euro rate interest and the number of employees, it is having a value more than zero point 0.9, that is 0.97 and 0.91 respectively. And then we have the euro rate interest with the number of employees, again it's 0.95. So scrolling down, so as expected, 3 pairs basically show a correlation coefficient higher than zero point 0.9, which is way too much. So here our indicators are two-way correlated, and hence we are going to deduct some of these so that we can reduce the correlation factor to a little extent. And scrolling down, so by doing this cell calculation, we have basically reduced the correlation. So zooming out the graph. Yeah, so now we can see that the correlation has considerably reduced, and now we have only 1 pair, that is the euro rate interest and the number of employees, which is having 0.95 correlation. So scrolling down. Yeah, so even if there's still a high correlation between the two variables, that is the euro rate interest and the number of employees, we are still keeping both the features, because this is probably a spurious correlation which states that this is a cause and effect relation, which is inevitable, and the other factors are not that much correlated. Next, we'll be moving forward with the Kramer's V formula. So this formula is basically tells us the association between two variables, the strength of association between two variables. And by doing some calculation, we can get a insight that, scrolling down. Yeah. So this graph basically depicts that the dependent variable, that is y, to how much extent the y variable is dependent on these features. So we have p outcome, month, age, contact, and all of these features. But among all the features, p outcome has the highest p value, which states that the y, which is a dependent variable, has high dependency on outcome rather than the other features. So moving down. Yeah, so high v value means an important dependency between the feature and the y variable. So next we'll be basically moving on towards the logistic regression model. And now I'd like to call Aditi to take us through the next steps.
So we have implemented logistic regression in our this many project. Logistic regression is a process of modeling the probability of a discrete outcome given an input variable. The primary difference between a linear regression and a logistic regression is that it is bounded between range 0 and 1. The sigmoid function which we have used, which the logistic regression uses, it maps any real value into another value between 0 and 1, and we use sigmoid to map predictions to probabilities. First, we have copied the bank data set into another variable, and we have removed and transformed the table data set by removing the unknowns. Later, we convert our variables to factors into ordinal variables, and we split the data into training and test data sets into the 80-20 ratio, where 80 represents the training data set and 20% represents the test data set. So in R, we use generalized linear models, which is JLM. This is handled by the GLM function. In this function, the Y binary is the output of the following columns, which are age, discrete, job, marital, education, etc. And we use there is family in which is binomial, which means binary classification. We also display the summary of the model. So we can see that the older age, higher education, contact over cell phone, and previous contact, all these columns, they seem to be highly predictive and positively correlated with a yes in the summary. We also see that jobs do not seem to have a significant impact. Similarly, our socioeconomics indicators do not turn out to be significant respect to Mr. Employed, NR employed. Precision and recall. So precision attempts to answer for questions such as what is the proportion of positive identification, and recall answers questions such as proportion of actual positives which was identified correctly. Here we predict the trained model with the help of the test data set. Thank you. So the mean is 89%, the precision is 90%, and the recall is around 99%. Hence, to conclude, we can see that P outcome, which is the outcome of the previous marketing campaign, which consists of failure, non-existing, and success categorical values. Contact, which is the contact communication of type, cellular, and telephone. A month, which has the last contact month of the year from January to December, and age, which is the numerical value. These features are instrumental in predicting if the person will subscribe to a term deposit or not, which this was evident through the Kramer's plot, which we had seen before.
ठीक है.
Thank you.
Thank you.